Engineer Yemi Opashade. Today we are here for another STEM communication. We are looking at an aspect of mathematics, and we are looking at an aspect of mathematics that is very interesting. We want to prove some of the laws that we have been coming across in mathematics in the area of indices. Laws of indices. Indices is an important topic in the mathematics. Any topic that we see begin from primary 2 down to the whole length of primary school to junior secondary school to secondary school down to the university. There is no engineering student, there is no anyone having scientific background that will not do indices in their under level in the university. So all through from DSS 2, indices has been occurring in our curriculum, in our syllabus, and so it is very important. Now, one of the backbone of indices is the laws. Now, some of us have passed through engineering, so many things, and some of these laws, we just cram them. We just know that they exist. I want to let you know through this communication that those laws can be proved. Now, what are laws? Laws are stated rules and guidance that must be obeyed by the generality of people. For example, every nation, every country has laws that guide its citizens. If you go against the law, then the law works against you. Again, currently in my country, Nigeria, there's a controversy in the recently conducted 2023 presidential election. And one of the bone of contention is that whoever emerges as the president must have at least 25% vote count from the Federal Capital Territory, Abuja, FCT. It has become a bone of contention that has taken them to court at the tribunal hearing stuff, okay? But do you know that that clause in the Constitution that emphasizes 25% or not can be explained? It's a law, can be explained mathematically. I don't want to go into that now so that I don't preempt the outcome of the judicial process. But watch out for my production in the topic called variation, partial variation. I will interpret that aspect of Constitution using mathematics. It's a law. So some laws can be proved. So today we are looking at indices. The indices proving the laws. Indices proving the laws. Now, indices is an aspect of math that has base and exponent. A base and exponent. This is called power. A raised to power, you call it A raised to the power of B. This is power. The A, which one is the one that is sitting, is the base. Take note of that. Then the B, which one that looks like as if you put a cap on your head, is called the exponent. Exponent. So this can be called power. The entirety of it is called power or index. So it's an aspect of mathematics that has a base and what? Exponent. So if I write 2 raised to power minus 3 now, this is a power. It's an index. The base is 2. The exponent is minus 3. And so exponent can be negative or positive. Now today, we are looking at all the laws. There's about 11 laws under indices. It may surprise you that there are, if you want to write out the detailed laws of indices, there are actually 11. 1 to 9, then 2 here, okay? So we want to see how we can prove some of them, okay? Some are self-explanatory, but some can be proved. So after this proving, you should be able to use your idea of these indices to solve this problem. And those of you that have registered fully, you have filled a form under this platform, anywhere in the world, you have the opportunity to respond to this question and send back to us through the medium of communication that has been established. You have got no reason not to be good in mathematics. Let's go. Now, the first law of indices is this. The first law of indices is this. Anything raised to power 0 is 1, except 0 raised to power 0. It is only 0 raised to power 0 that is not 1. But any other thing, for example, in this case now, I wrote A raised to power 0 is what? Is 1. 2 raised to power 0 is 1. Nigeria raised to power 0 is 1, because there is only one Nigeria. 2 over 3 raised to power 0 is 1. Square root of 3 raised to power 0 is 1. What is your name? Jeremiah. Jerry. See here now. And so if you have ax plus b bracket raised to power 0, it is 1. We want to prove why this is 1 and why 0 raised to power 0 is not equal to 1. As a matter of fact, 0 raised to power 0 is 0. We are going to prove it. So this one is a 2-in-1 proof. Okay? Are you ready for the proof? Let's go. I want to clean this. Don't forget, anything raised to power 0 is 1. Now, let's use that. I want to prove that a raised to power 0 is equal to 1. Let's see. Now, don't forget that if you write a, 0 simply means 1 minus 1. Or if you like, it means 3 minus 3, anyone you like. So, instead of this 0, I've replaced it with 1 minus 1. Now, I can break this up as 1 raised to power 1 times, a raised to power 1 times a raised to power minus 1. Do you see that? Because law of indices, there's a law we'll come across very soon that says if you have a common base, what you do is that you add 1 plus minus 1 is 1 minus 1. Now, there's a law that if the exponent is negative, you can remove the exponent like this. This will be a raised to power 1 dot. This minus means 1 over, take note of that, this minus to disappear. It means 1 over. You will not write everything below except that minus. Okay, now let's see. Look at this. This becomes a raised to power 1 times over, because this one time is this, then this one is still down. Do you see that? Now look at it. They look alike. Now I can cancel this as 1, so it is 1. If you use this, look at the same thing. If you split it into a raised to power 3 times a raised to power minus 3, this comes down as a raised to power 3, this comes down as a raised to power 3, and this cancels this, that gives you 1. Okay? Now let's now look at the reason why 0 raised to power 0 is the only exception to this rule. It is only 0 raised to power 0 that will not give you 1. 0 raised to power 0 is actually equal to 0. Can we prove that? Okay, let's go. Now if you look at this, again this 0 is 1 minus 1. The 1 minus 1 is 0. Now I can split this like this. 0 raised to power 1 dot 0 raised to power minus 1. Then this is 0 raised to power 1. If I want this negative to disappear, it will be 1 over then 0 raised to power what? 1. Which means 0 raised to power 1 over what? 0 raised to power 1. Which is 0 raised to over 0. And that will give you 0. Okay? 0 cancelled by 0 will give you 0. It can't be 1 in this case. That is the only exception. Is that clear? Alright. Now let's go to rule 2. Rule 2 says a raised to power 1 is equal to a, meaning that anything raised to power 1 is that thing. Anything raised to the power of 1. 2 raised to power 1 is just 1, 2. Nigeria raised to power 1 is Nigeria. 1 over 2 raised to power 1 is 1 over 2. 100 raised to power 1 is just 100. Is that clear? Now let's see how we can prove this. Now, we want to prove that a raised to power 1 is a. Now, what you do here is this. Try and replace this with two numbers combined together that can be 1. I can say a is equal to what? A raised to power 2 minus 1. 2 minus 1 is still 1. Now, let's see this. Let's split this into 2. A raised to power 2 times a raised to power minus 1. Okay? Law of indices, split it. Now, don't forget, minus 1. This is a raised to power 2. Okay? If you want this minus to disappear, it will come down as a raised to power 1. Now, the meaning of this is this. This is a in two places, a times a. Over this one is a in one place, a raised to power 1. That's a. This a cancels this a. What we have left is what? A. So it means that anything raised to the power 1 is that thing. As in this case now, a raised to the power 1 is a. Can you see that? All right. Now, let's look at another law and try to prove it. Now, another law says if you have a raised to the power n times this dot means times a raised times b raised to the power n, they have common exponent and they are being joined by multiplication. The law says you can bring the a and b together so that they can have a common exponent because the exponent is the same thing. Is that clear? So we want to prove that a raised to the power n times b raised to the power n is the same thing as a times b raised to the power n. Now what to do in this case is this. Try and prove it this way. Let's assign number. Let's say this is 2 raised to the power 3, 1 raised to the power 3. Do you see that? Now, if you look at this law says this is equal to 2 times 1 raised to the power 3. Do you see that? Okay, let's prove it. That's what the law says. So 2 raised to the power 3, that is 2 times 2 times 2. Then 1 raised to the power 3, that is 1 times 1 times 1. Now, look at this. What is 2 times 1? 2 times 1 is 2 raised to the power 3. And what is the meaning of 2 raised to the power 3? It means 2 times 2 times 2. Now let's check this. What is 2 times 2 times 2? That's 8. 1 times 1 times 1 times 1, that's 1. 1 times 8, that's 8. This one, 2 times 2 times 2, that's also 8. So it means that this law is valid. If the exponent is the same thing, then you can bring this together so that they can have a common exponent. Thank you. Now, can we go to another law? Okay, let's try to see another law. There's another law that says that if you have a raised to the power n, raised to the power n, two exponents, m, n are exponents. The law says the exponent can be multiplied if you remove this bracket. So we have a raised to the power mn and mn is a raised to the power mn. Now let's try to prove that. We want to prove that a raised to the power m, one exponent, and another exponent is equal to a raised to the power m times n. Now let's prove this. We want to prove this. So the easier way to prove this is to assign figure. Let's say this is 5 raised to the power 2, then raised to the power 1. Just choose small number. Don't use number that will give you too much headache. This is equal to, according to the law, 5 raised to the power 2 times 1. Exponent can multiply each other. That's the meaning. Now, look at this. The meaning of this is that this 5 raised to the power 2 exists how many times? One time, once. That is 5 raised to the power 2. That's all. Then here, this is 5 raised to the power. What is 2 times 1? 2. You can see that we get the same answer. This is 5 times 5. This is also 5 times 5. What is 5 times 5? 25 equals 25. It means that this law is valid. All right. Now, yes, this one is very interesting. Can we see that? The next law. It says, look here. I've actually applied this law in proving the preceding laws. Look at it. A raised to the power minus 1. Most times when the exponent is negative, we want the negative to disappear. This negative means 1 over, then the negative disappear. You now have everything here except the negative. That's a raised to the power 1. You remember that a raised to the power 1 is what? A. That's why we have 1 over a. So we want to prove to you now that a raised to the power minus 1 is actually 1 over a. Okay, let's see how to do this. Now, again, you will replace this number minus 1 with 2 numbers such that it will still be minus 1. Okay, I want to use a raised to the power 1 minus 2. 1 minus 2 is minus 1. Okay, now let's split this up into a raised to the power 1 dot a raised to the power minus 2. Now, this is a raised to the power 1 dot this negative. If you want it to disappear, it means 1 over. Take note of that. Don't forget that. Then you write everything now except that minus. Is that clear? This is equal to a raised to the power 1. Sorry, over 1. Raised to the power 1 over a raised to the power 2. How many a is this? A raised to the power 1, according to the law, is a. So you write a. A raised to power 2 means A times A. A here 1, A here 1. So 1 is equal to 1 times A, that is 1 over A. So it means that A raised to power minus 1 is actually 1 over what? A. Now I want to go into another one. Okay, can you see that? Okay, take note of those proving as we are doing it one by one. You can rewind to be able to get it appropriately. Now the next law says if you have A raised to power m times A raised to power n, that is equal to A raised to power m plus n. Look at this law. This could be interesting. If the base is common, if they are more than this, once the base are common, pick one of the base and add the power. For multiplication, for times, it is addition. For times, it's addition. If it is division, you will subtract. Okay? So now let's pick some few things here. Let's say we have 8 raised to power 3 times 8 raised to power 2. According to this law, it says that it is written as 8 raised to power, I will add the 2 powers, 3 plus 2. Now let's see. But you know the meaning of this one is 8 times 8 times 8. The meaning of this one is 8 times 8, 8 in 2 places. And this is what? 8. What is 3 plus 2? 5. Now, how many 8 is this? We have 1, 2, 3, 4, 5. That is 8 raised to power 5. And at this side, what do we have? We have 8 raised to power 5. Can you see that they are the same? So it means that A raised to power m times A raised to power n is actually A raised to power m plus n when they have a common base. Take note of that. If the base is not common, you cannot apply this law. Okay, the next one is A raised to power m divided by A raised to power n. If it is division, common base, the exponent will be subtracted. Okay, let's quickly prove that. You have A raised to power let's say m divided by A raised to power n. If it is division, common base, you pick one of the base, then you subtract m minus n. Okay, let's look at 8 raised to power 3 divided by 8 raised to power 2. According to this law, it means 8 raised to power 3 minus 2. Now, the meaning of this is this. 8 raised to power 3 means 8 times 8 times 8 divided by, this means over 8 raised to power 2. That's 8 times 8 again. Then this is what? 8 raised to power. What is 3 minus 2? 1. Now, this 8 cancel this 8. This 8 cancel this 8. How many 8 do you have left? 8. Then this is 8 raised to power what? 1. Don't forget that anything raised to power 1 is that thing. So that means this 8 is also equal to what? 8. Because 8 raised to power 1 is 1 8. Can you see that this law is actually correct? Finally, because this one, I'm not going to prove this. I've already proved this inside of this. The last one is this. We want to prove if you have a fraction and the exponent is negative. If you want the exponent, the negative to disappear, you will just interchange. Denominator will come to the numerator and numerator will come back to the denominator. Once you do that, the minus has disappeared. Okay, I think we need to prove that. Let's quickly prove that. Now, we want to prove finally now that A over B raised to power minus x is actually equal to interchanging numerator with denominator. B over x, over B over A, for the negative to disappear. Now, how do we prove this? Now, you will recall that I've already told you that if you have A over B raised to power minus x, if you want this minus to disappear, it means 1 over, you will write everything A over B except that minus raised to power x. Now, the meaning of this is this. This one is this. This line means division divided by what? A over B raised to power what? X. Now, in mathematics, from the elementary mathematics, we know that if I want to change this division to times, B will go up, A will come down. But the X, the exponent, still remain where it is. Now, if you multiply 1 by anything, it is that thing. So this will give you b over a raised to power x. Can you see that a fraction raised to power a negative exponent will be equal to that fraction in a reverse form, making the negative to this side here. Oh my God, very interesting. We're able to prove 9 laws of indices. All these ones are just application. Look at this, for example. I said you should find, like this question number 5 now. You will use this to solve this. Now let's say I give you 9 raised to power x is equal to 3. Now if you look at this 3, this 9 can be expressed in terms of this 3. That's 3 raised to power 2. Then raised to power this x equals to 3. Now according to the law of indices, exponent multiply exponent, that will be 3 raised to power what? 2x is equals to 3. Now, if you have 3, it means 3 raised to power 1. Don't forget, a raised to power 1 is a, meaning that a is also equal to what? 1, a raised to power 1. If a raised to power 1 is a, it means a is also equal to a raised to power 1. So if you have 3 also means 3 raised to power what? 1. Now, if you look at this law, bring it here, look at this law. Base cancel base in an equation. This is an equation because this index equation. Okay, then m will be equal to n. Sometimes exponents, once they are the same, they cancel. Exponent m, exponent m. That means the answer will be b equals to what? C. Okay, let's come back here now. This has a common base. 3 cancel 3. So what do you have left? It means 2x is equal to 1. If 2x is equal to 1, I'm looking for x. I will divide both sides by 2. So that means x will now be 1 over 2. So that is just application. The law has been proven. I hope you enjoyed this class. Follow up by sharing, by the subscribing, sharing, and supporting. Till next time we meet, you have a great moment. And don't forget, do not go against the law of the land.
The club isn't the best place to find the lovers, so the bar is where I go. Me and my friends at the table doing shots, tripping fast, and then we talk slow. And you come over and start up a conversation with just me, and trust me, I'll give it a chance. Now take my hand, stop it, and the man on the jukebox, and then